Catholic tradition, each saint is supposed to. They're a bit like X-Men. Each saint has a special ability. It's the best way I can explain it. So you know, Saint Anthony, he has the special ability to help you locate things you've lost.
Oh, this is fun. I should make a wish.
Let's see now. Who else now? Who else is there? So I shouldn't perhaps really be comparing saints to X-Men, but it's...
So isn't it when they die? I mean, they become saints when
Yeah.
they die.
Yes, and then they become superheroes.
Yeah.
Saint Anthony, Saint Christopher, that's the other one. Superpower of helping travellers on journeys. Yes. It's a little bit, I find it a little bit strange. Anyway.
Strange.
It is a little bit strange.
Pretty really we should.
It is a bit strange.
We should. Anthony. Oh, this is fun.
Okay, continuing now. Gary! Lee! Chrissy! Chew! Come on! What?
Monica!
She has her stuff ready. Just like these guys.
I have this ready.
You're on your phone!
Wow. Really?
I told you. Make a wish.
Really?
Come on, you come to teacher, the Stan story is in Ireland.
The what story?
The Stan.
Saint?
Saints do.
Yes!
Oh, in church, it's not in Ireland.
No, it's
No,
Catholic.
it's a Catholic thing.
I was thinking,
Saint Maria.
I'm here so I adapt the culture.
Oh yeah.
Okay. St. George is the coolest because he killed a dragon.
What?
St. George killed a dragon.
But he has no power to be bishop.
You're saint.
Well, if you're ever facing a dragon...
Oh.
Alright. So, we saw in semester one application of integration. What was that? Area. We can integrate and it can help us find the area. So, for example, if I have something like this, A to B, and I would like this area, then I simply have this formula. Easy peasy. Now, what's really nice is, believe it or not, you can actually use integration to find volume. But it's a volume in a very particular way. For example, if you have a shape like this, and here is A, and here is B, you need to imagine that you spin this around the x-axis, and it would make a sort of shape like this. Oh, I can't even, it's hard to draw, but in this picture it would make a shape like this. You can actually find the volume here precisely. And the formula for finding volume, it's not too different to area. No. Nice try.
Q.
No. Has a pi in it. You are actually close, believe it or not.
Pi RQ.
No, Jerry was the closest. No, Jerry is right, as he was joking saying pi r squared. But the reason for the f squared is because it's like an r squared. If these are all like cylinders.
Teacher, is this 3D or 2D?
3D.
3D.
2D.
How about 4D?
Wait, can I have like two formula for the another?
For what?
Oh, which one has acceleration?
Yeah, now for us we just care about rotation around the x.
Oh, that's fine.
The syllabus specifically says not to do the y, just to do the x.
Oh.
But believe it or not, if you rotate around the y, it's actually not really any different, the formula. So if you have a shape like this and you rotate around the y, and this is A and this is B here, anyone want to have a guess at what the volume might be? It's still pi A to B, but it's not fx. Very good, KJ. F inverse squared dx. It makes sense because you're looking at this. But you're the one who said this, and you were right. Are you confused?
No, I mean, no, not concerned.
Okay, right. But this, don't worry, is not on the syllabus. They just want you to look at this one. Yeah? So can we do some examples of this now? Oh, and I should point out, it is impossible for this to be negative. It has to be 0. Not only because it's volume, because of the square. If you ever got a negative answer, you screwed up. You screwed up big time.
Oh, I'm not talking about the volume. I'm talking about the x equal to something, so they shape like this, and you have another shape inside, so is minus inside, therefore.
I guess so. I don't really know what you're saying. But you're right, if there's a shape where there's a hole in the middle,
yeah,
then it would be a subtraction. Yeah.
yeah. Right.
But we don't, for our exam, we're just looking at straight rotation around the x with no holes in it. Yeah. Okay. Can I do some examples? Yeah. Right. I want to begin with an example that we know the answer already, so we can see it work in progress. So if I have something like this, this is x, this is y, this is 0, this is 10, and this is 2, and I have this curve here, which is just a horizontal line, y equals 2, or rather, fx equals 2. What happens if I rotate this? What shape do I make?
Triangle. Rectangle.
No, it's like this.
Cylinder.
Oh.
Makes a cylinder.
Cuboid.
Oh, that's
Please stop talking, Lee. Right. It makes a cylinder. Now you know the answer for this already. The volume of a cylinder is pi or squared h. So it'd be 40 pi as the answer. Yeah. 40 pi, yeah. What? Pi or squared h.
H is 0.
H is not 0. If h was 0, there's no volume.
Oh, yeah. H is 4.
No!
Oh, H
is 10. Is this okay? That was supposed to be the easy part. Can I continue?
Yeah.
Yes? So, we should get 40 pi. Let's see. Integrate pi 0 to 10 2 squared dx. That equals pi 0 to 10 4 dx, which equals pi 4x 0 to 10, which equals pi 40 minus 0, which equals, as I said, 40 pi. That is our first example. Write it down, we'll do more. What's wrong, Sean? You don't want to write this down? Sean likes to think deeply about what I do. Deep thoughts. Nobody does to me. They're just jealous. What's so funny? Calm yourself down, please. Alright, did you write this down? No. Calm down, Monica, calm down. Come on, what's taking so long? I see 3 people still writing. I'm full of patience. That's my superpower.
Johannesburg.
He's alright. He doesn't want to write anything down because he wrote it down already. So he's sitting there. I said, write it down. He says, I wrote it down. I said, did you write it down today? I'm lazy. Like you. I'm like, okay, that's true, but I still want you to write it down. Okay, continue. Right, let's have a look at a little bit of a harder one. So let's take something like this. Fx equals 2x. And again, let's make it 0 to 10. X, y. I'd like you to try and get the volume here. But before you do, tell me what shape is made. Cone. Cone.
Oh,
Makes a cone.
yeah.
Good. Calculate the volume.
Yes.
Yeah.
Too fast.
Still? No. Pi
No.
f squared, yeah. Finished already, KJ? Too easy? Or too smart? Nah, only one of those things is true. Which one? Getting any faster on the skateboard?
Yeah.
Yeah. Are you at top speed yet? You are?
Yeah.
At the 32?
Yeah.
Good man.
It's not that far.
32?
Yeah, after I use
After a while. So, it's like addiction now. You're like, I've got faster.
Yeah.
42, 52. Maybe you can put a bit of NOS in it. You know, he knows it, don't you? NOS?
Nitro.
Yeah, nitros. What?
Like booster.
Yeah. You know, Fast and the Furious?
Yeah, need for speed.
You need for speed, yeah. Maybe you could help him modify his skateboard, you know. You could put some lights underneath it, maybe get some nice sound system as you're skating along, you know.
How can I actually?
A little spoiler at the back, a little, you know.
Yeah.
Here's the, little spoiler at the back, maybe some lights underneath, speaker up the front. How else could we modify it? A bit of a nitrous exhaust out the back.
What? Make it a wing.
Put a F.
Oh,
F1
yeah.
engine.
F1 engine mounted on the back. Because you said 32 is too slow now. And we need to maybe. Yeah, no, actually, good question. Because it has a DC motor in it. It would have a DC electric motor in it. So you know the formula, the torque is IBAN. Now you can't change the B. You can't change the A and the N. But you might be able to change the current. Maybe put in a more powerful battery. Think about it.
You should have that.
If you go fast and change the chapter, you can fly.
Yeah, that. Right. Pi 0 to 10, 2x squared dx. That's pi 0 to 10, 4x squared dx. That's 4 pi integrate x squared dx 0 to 10. So that's 4 pi x cubed 0 to 10. We put the 10 in and cube it at the 1,000, isn't it?
Yep.
So 4,000 pi.
It's x cubed over.
Oh, sorry, thank you. Over 3, so I
Yes.
guess here. Got that?
Mhm.
Okay, let's have a look at a harder one now that we have the basic idea. Yeah, well, it's this, the formula here, circular, correct, yeah. So that's the formula for this graph. And you're right, when you rotate it, it makes a sphere. Okay, calculate. Not telling you, you'll have to work them out.
What is R?
Your A and B can contain or. Treat or as a constant that you know. Your answer can have or in it.
Oh.
No, you can't. You can find exactly what those 2 points are. No. Y is 0. They're the roots.
Huh?
They're the roots.
X equal minus
Yeah, no, you're right. You simply need to find the roots. So, just that which is equal to y. That's the graph. So you're just looking for the 2 roots when y is 0. Or rather the other way around, x is equal to or. But there's 2 solutions.
Y equals 0.
Yeah.
It means fx is 0.
Come on, obviously this here is minus or and this is or.
Oh yeah?
Obviously. Because that's the only way to make 0 on the y, which are the roots. X, or squared minus x squared needs to equal 0 for those 2 roots. What?
Central point is
0. Yeah. Yes, the center point is 0.
Yeah.
It's false.
Yes.
What?
But do it.
I did it. Not math.
Uh-huh.
So if x
Math.
equal to 0, y also equal to 0.
Yeah. But I don't care about up here. I only care about these 2. The start and the end.
So answer has 0.
Yes. Stop saying 0. What are you talking about? What is the problem here? Alright. Yeah?
Nothing.
Is this correct?
You missed a 2 somewhere. You lost a 2.
Me?
Yes.
Am I?
Oh, very. So, let's have a look. B equals pi integrate minus or to or root or squared minus x squared squared dx equals pi integrate minus or to or squared minus x squared dx equals pi x or squared minus x cubed over 3 minus r to r equals pi something minus something. R cubed minus r cubed over 3 minus r cubed plus r cubed over 3. So the r cubes here and here cancel, and that's I made some sign mistake here, didn't I? That's a plus 2 minus oh yeah, sorry. Actually, what am I doing? I should simplify this a bit first. Sorry. Pi 2 over 3 r cubed minus 2 over 3 r cubed, which is pi 4 over 3 r cubed, which is 4 over 3 pi r cubed.
That's a minus.
No.
I mean, r cube at the top.
No minuses.
Oh no, go up and go up. No.
Here? Here?
Yeah.
Here.
Yeah,
What's
minus
wrong?
r cube plus minus r cube.
Hang on, let me check. That is an r cubed. That is correct.
Yeah,
That is a minus.
correct.
Yeah, because I just put the or in here.
Oh, we changed the sign. Sorry, I'm new.
Yeah.
Oh.
No, you don't.
Stephen,
What?
can you don't change the r square minus x squared to y square? I mean to y. I mean x squared plus y squared equals to r squared, right?
Yeah.
So we can change it that fx equals to y, right?
But that's
We
not
can
good.
choose y
No,
and
because
y.
you can't mix letters. It has to be an X.
Oh, that's
Yeah. Okay, next one. Next one. Yes? Okay, scroll down. 2. 10 seconds. Oh, okay.
Formula is from here.
3, 4, 5, 6, 7, 8, 9.
Well, there's many ways to prove the formula. This is just one way. The formula is actually 2,000 years old.
This one.
Yeah, but not done this way, because this method only existed since Newton. This is one way to prove the formula, but the formula itself existed for 2,000 years. Now, how they proved it without using this, I really don't know. I'd have to look it up. Because 2,000 years ago, they didn't have calculus. They didn't even have algebra.
Teacher, they can use water, teacher.
Perhaps, yes. Perhaps you're right. Maybe they just proved it by experiment. But I don't think so, Jerry. I think they had the exact formula. Yeah.
Oh!
I told you.
Why you do
Why you really?
What?
Really?
We are so slow.
Give them a minute.
What's wrong?
Okay,
They only realize now this is the formula in physics.
Okay. I did it.
Okay, next one. Okay, try this one for me. This is X, this is Y, and this time I'm making it a little bit different. You have to find the formula first. So this point is 0, 0, and this point here is H, or. And I rotate it around this way. Okay, try this one. H, R. H.
What is that? B or?
Oh, that's all.
C?
Ah, 1 minute.
We know
Yes,
that.
but if you think about your first lesson in semester 1, week 1, equation of the line, I give you a formula to find the gradient.
It's
What?
not 0, 0.
Yeah.
But we need 2
2
points for
K
that.
equal H4R.
Yeah.
We need 2 points.
If only I drew 2 points on the graph. Wait a second. I did.
Y equal hash x.
Yeah, you want us to include that again?
Y equals what?
Hash x.
Oh no.
I know the answer. 1/3.
Ah, come on guys, don't be ridiculous please. You know what the M is here. What's the M?
ROH.
Yeah, thank you. So don't be ridiculous. So what's the equation of this line? Yeah, so what's the equation of this one?
Y equals R over HX.
Yeah.
It's the Y. Yeah.
That's the formula for this line.
Oh.
The C is 0.
Plus 0.
Yeah.
Yeah.
So give me the volume.
Oh.
You have it in the picture?
H R squared minus R squared over H squared.
I'm sure you can simplify that.
What?
This is the formula for cos.
Yep. Simplify, Charlie. Simplify. Okay, let's have a look. So the volume is, oh right, okay, let me just write the question down then. So, this is pi r squared, h squared, x squared, integrate. Okay, so that is r squared pi over h squared, x cubed over 3, 0 to h, which will be r squared pi over h squared, h cubed over 3.
I get it.
Which would be 1/3 pi r squared h.
Aha.
Yeah. Okay. Let me give you one more. Hold on. Okay. And this is parallel. H or. And it's rotated this way.
So why do I get different answer from this example? Let's call this.
Huh? What are you talking about, man?
I use 1/3 pi r squared h pi. I get different answer.
What did you use as the H?
The h is this 10.
Yeah, and the R?
20 equals 2x. And it's 4,000 something.
And what did you get?
1,333.
But over 3.
Nine.
Not divided by 3.
Huh? Oh no, it's because there's a pi there.
Yeah.
So why we use like weakling spaces?
Yeah, well, not always.
There is not.
Not always. Because if you have a graph like this, yeah. I'm just picking examples where they are in physics. I'm trying to show you, Jerry, that these formulas where they come from. Do you know what I mean?
Now how do you know V equal pi?
Yeah, how do I get the formula at the beginning?
Yeah.
There is a proof.
Huh?
There's a proof of this formula. But what you said earlier today, the pi r squared, that's actually pretty close to the proof. Because what happens is, Jerry, you picture this as being lots of cylinders, like lots of discs, and each disc would be pi r squared, and this one here is pi r squared. But the or is actually this, so that's pi fx1 squared plus pi fx2 squared. And if the x1 and the x2, if they're all nearly the same value, if they're close together, if they're neighbours, then actually you can say that this total actually becomes this. This changes into this when all the numbers are close together. The proof is a little too difficult for this course, but you can prove it. Alright, do we have the answer here? Pi from 0 to h, and the function r squared dx. So that would be pi or squared x 0 to h. Put the h in, you get pi or squared h, which of course is the formula for the cylinder. So we've actually proved the formula for the cylinder, the cone, and the sphere, using this one formula. So this formula works for any shape. An example of where this is important is the one I was talking to Jerry about. So this graph here, fx equals root x, let's say from 0 to 1. There is no formula to get this shape. In fact, what is this shape even? It's not quite as circular as a hemisphere, because a hemisphere wouldn't quite be like this. It'd be it's squared. It'd be more like this. It's not quite in line with a hemisphere exactly. So it's not actually a hemisphere, nor a quarter sphere, or any kind of particle sphere. Well, there is no shape. It's a unique shape. So why do we care about such a problem? Well, because this is exactly the shape of on the side of your house, the satellite dish. Yeah, it's exactly the shape. Not close to, but is exactly a root x shape. Now the reason for this is because this graph has special properties when it comes to reflection. So for example, there's a point here called F, and what's special about it is anything that comes in parallel to the x-axis, yeah, when it hits the dish, they all get reflected to F. Now this is unique to this graph here, and useful, because it means when you have a satellite coming in from space, it's obviously quite weak because it's spread out over a great area. So what the dish does when the information comes in, it's too weak, but when it bounces off the dish, it all collects together at one point and becomes stronger. So it's like you take this area, maybe we'll say 1 meter squared, and make it reduce down to only like about this size, which is like 4 centimeters squared. So you can, it's like you can strengthen the signal. You get a stronger signal. So, you know, this is why this is useful, because you can answer engineering problems that you don't have formulas for. So I think it's very, very interesting. You know, because why would you need to know the volume of this? Well, you might need to know the volume, you know, for construction, like how much space is it going to take up? Or you might want to know what the weight is. You know, density is mass over volume, so the mass of it will be the density by the volume. Well, the density you know because it's made of a sort of a metal, but you would need to work out the volume before you can calculate the mass. Otherwise, how would you know the mass? You would have to make it and then weigh it? Oh, that's a waste of energy. So it's very, very useful. Very, very useful. I'll let you try some of these for a couple of minutes, okay? It's not too hard, it's just using the one formula. Can I close this picture? Yeah? Or do you need to write it? This one? What's wrong? Leave Jerry alone. Do your question, please. Thank you.
Oh.
No. Nothing happened. Monica is bullying you. Are you scared of Monica?
Yeah, obviously.
Yeah. You don't want to sit beside Monica? She's trouble, isn't she? Monica's a troublemaker. Did you know this?
She's not funny.
She's a what maker? Oh, not? Are you sure? Monica? You don't think so?
I think so.
I think so.
But, yeah, dangerous.
You know, like I see her on the bus sometimes, and I can tell you when people get on the bus, they look around, there's nowhere to sit except the seat beside Monica, and they look, and then they stand. I've seen this happen. Do you know how I know this happened? 'Cause that's what I would do. Look, it's fine, Monica. You know, it's a good thing. It means nobody will ever mug you. They wouldn't risk this. No, let's not go that extreme. No. You don't. Now, I said you look like a troublemaker, not a mugger. I mean, you know, get the level right. Chew. Can I close this now?
Yeah.
Yep. Thank you.